Hello class. So in this video, I will be giving you an introduction to differential equations. So in physics, we frequently need to represent phenomena or a phenomenon using equations para ma-relate natin yung mga variables nila. Like let's say for example, the velocity of a moving object. So nire-represent natin siya as an equation. Diba the velocity of a moving object, we just express that as distance over time. Now, importante na gawin natin yun in order for us to perform operations on their equations and find the value of unknown variables. So another example is ito na nasa PowerPoint presentation natin, which is the equation relating the final velocity of an object under constant linear acceleration. And that is Vf is equal to Vi plus At, wherein Vf class is the final velocity, Vi is the initial velocity, acceleration naman yung A natin, and yung T is time. So this is a very simple equation ng physics. Very familiar naman tayo dito. And alam natin na itong bawat variable na to, they just represents certain numbers or certain values. And if we have those values, pwede nating masolve yung mga unknown na parameters natin as long as we have enough given. Now, the problem is, hindi lahat ng physical phenomenon ay ganyan kasimple. Some physical phenomenon cannot be modeled as such na ganun kasimple. Some equations contain variables that change with respect to changes to other variables. When I say that, ibig ko sabihin, halimbawa, we have a variable x. Let's say, rather, a variable y. Pwede na may mga physical situation or real-world na problems kung saan kapag nag-change yung value ng isa pang variable, let's say x, ay mag-change din yung value ng y natin. So, kapag ganun na yung tinutukoy natin, na kapag nagkaroon ng small change in x, magkaka-change ka ng y. So, basically, may rate at which this changes with respect to another variable. Hindi na natin siya kayang i-model ng ganito kasimple. This is just an algebraic solution or algebraic equation, di ba? So, hindi na natin siya mamomodel ng ganyan. So, ang tawag natin doon, yung rates na yon at which nagbabago yung mga variables natin, ang tawag natin doon ay derivative. So, derivatives. So, derivatives class, this can be defined as the rate of which a dependent variable, let's say for example, y, changes or is changing with respect to an independent variable, let's say, x. So, dependent variable y, independent si x, nakadepende yung value ni y kay x. And in-express natin siya as, if susundin natin yung definition ko kanina, as dy over dx. So, ang tawag natin ngayon sa mga equations na nagko-contain ng derivative ay differential equations. So, the definition of a differential equation, it is an equation involving derivatives of a function or functions. In applications, the functions usually represent physical quantities, and then the derivatives that represents the rates of change, and the equation that defines the relationship between the two. And it is used to model and simulate physical phenomena. So, meron daw tayong isang physical quantity, yan yung mga variables natin. Tapos yung derivatives nila, tapos nire-relate siya ng differential equations natin. And we use it to model a physical phenomena. So, lagi nating tandaan yun. In mathematics, hindi lang tayo nagmamath para lang mag-solve ng problem. Halimbawa, matutunan lang natin kung paano ba yan ginagawa. No. Ang endpoint natin lagi with differential equations or with math in general is to be able to use it in real-world problems. So, yun yung target natin dito. Itong buong SEM na to, this will be moving forward or moving towards solving real-life physical problems. So ito, we have some examples of differential equation and ganito rin natin siya ina-express kung paano ba yung notation kumbaga ng differential equation. Ito, we have dy over dx. So obviously, this is the derivative is equal to e raised to x plus sine x. Ito naman yung physical quantity natin, yung x. And nire-relate siya ngayon itong equation natin. So this is a differential equation. This is also a differential equation. This is second derivative naman. Na-express natin ang second derivative ng ganito, d squared y over dx squared. We also can express a differential equation like this. So yung dependent variable natin ang gagamitin, in this case y, tas prime na symbol lang or apostrophe. So kapag dalawa yung prime, then sabihin this is second derivative. So this is also similar to d squared y or the second derivative of y with respect to x. And yung y prime, that's dy over dx plus y is equal to cosine x. So this is a differential equation. Ito naman, instead of using d, ang ginamit natin symbol is ganito. So ano ba yung ibig sabihin nitong symbol na to? Ang ibig sabihin lang niyan is partial derivative. So hindi siya same nung d lang na operator kumbaga. We are using partial derivative. Matututunan pa natin yan in the next na mga topics. Where in these equations, yung dx natin, pati yung dy, etc., ang tawag natin doon ay differential. And it represents an infinitely small change in that variable. So kung yung dx, it represents a small change or infinitesimal change in x. So kapag dy, o ganun din, it represents an infinitely small change in y naman. Ganun din sa dt, and so on and so forth. Ang tawag natin doon, differential. Pero kapag kinuha na natin yung ratio nila, ang tawag na natin doon ay derivative. So yung example ng derivative dito is dy over dx. So that is the derivative of y with respect to x, or simply can define as the ratio of differential of x of a differential of y relative to the differential of x. So nakuha ba? Kaya mahirap i-define kasi baka sabihin nyo, sir, ganun pala pag nagbago yung value ng y, magbabago yung value ng x, etc. Hindi ganun kadali siya i-express kasi we are trying to express infinitesimal changes. Hindi siya yung changes na kaya nating i-quantify. Na, halimbawa, nag-change ng 1 to, nag-change din to ng 1 or something. Hindi ganun yung pag-express natin ng differential equation. So, next is, ano daw ba yung solution to differential equation? So, the solution of a differential equation is a function or a set of functions. As opposed to algebraic equations, ang solution natin ay integers or numbers in general. So this is an example of an algebraic expression. We have x squared plus 3x plus 2 is equal to 0. If we find the solution or get the value of x, we will arrive at x sub 1 natin is equal to negative 2 and x sub 2 natin is equal to negative 1. So ano ba sabihin yan? Kapag solution, sinabi natin that negative 2 is a solution to this algebraic equation. Ano ibig sabihin nun? Ibig sabihin nun, kapag sinubstitute mo to dito, sa equation na to, masasatisfy yung equation. Ganun din, kapag sinubstitute mo tong x sub 2 or yung negative 1 dito sa x natin, sa algebraic equation natin, masasatisfy din yung equation natin. So, kung ganun yung mangyayari, try natin, mental na lang natin. So, negative 2, substitute natin dito. So, we have negative 2, that is raised to 2, that's positive 4, plus negative 2 times 3, that is negative 6, plus 2 is equal to 0. So, that's 4 minus 6 plus 2, that is equal to 0. So, nasatisfy yung equation. So, therefore, this is a solution talaga. So, ganun din dito, if we substitute negative 1 sa x, makukuha din natin is mag-equal din siya sa 0. So, this is also a solution. Now, for a differential equation naman, ang solution nating class is a function. As compared dito sa algebraic expression natin, ang solution natin is numbers. Ang solution natin dito is a function. So to be specific, we have a differential equation y prime or y double prime plus 2y prime is equal to 3y. Ang solution daw natin is, one solution is y sub 1 of x is equal to e raised to negative 3x and the other one is y sub 2 of x is equal to e raised to x. Kung napansin, dito, variable ang gamit natin, dito, function na. Di ba ganyan natin in-express ang function? Y sub 1 of x, kumbaga, ang functions in-express natin as ganito, a function of x. Meaning, this function is dependent to the value of x natin. Which in this case, ang variable natin is, yun nga, yung x nga. So, dapat, pag sinubstitute natin tong e raised to negative 3x dito sa y double prime plus 2y prime is equal to 3y, masasatisfy din yung equation natin. So, ito daw, example. I-substitute natin yung dalawang functions natin na solution dito sa y double prime plus 2y prime is equal to 3y to validate kung tama yung general solution natin. So, una muna tayo sa y sub 1 natin. Oops, mali. Ayan. So, y sub 1 of x natin, which is equal to e raised to negative 3x. So, kailangan natin siyang i-substitute dito. So, para magawa natin yon, kailangan kunin muna natin yung first derivative tsaka yung second derivative nitong function natin. So, take natin yung first derivative nito. So, y sub 1 prime of x. So, that is, kunin natin to, differentiate natin. That is negative 3 e raised to negative 3x. So, may first derivative na tayo. Second derivative naman, we have y sub 1 double prime is equal to x. This is positive na. Positive 9 e raised to negative 3x. Now, next na gawin natin, pwede na tayo mag-substitute. So, pag substitute natin, this will be y double prime natin is 9 e raised to negative 3x. Tapos, plus 2 times y prime natin is negative 3 e raised to negative 3x. This is equal daw to 3y. Ang y natin is e raised to negative 3x. Makakuha natin to. This will be negative 6 e raised to negative 3x. So, 9 e raised to negative 3x minus 6 e raised to negative 3x. We will arrive at 3 e raised to negative 3x equal to 3 e raised to negative 3x. Na-satisfy yung equation. So, therefore, this is a solution to this differential equation. Next, solve naman natin. Gamitin naman natin yung y sub 2. So, yung y sub 2 of x natin is equal to e raised to x. Ang madali lang to. Kasi ang first derivative niyan is also e raised to x. And then yung second derivative is also e raised to x. So, pag sinubstitute natin yan dito sa equation, y double prime is e raised to x plus 2 e raised to x is equal to 3 e raised to x. We will arrive at 3 e raised to x is equal to 3 e raised to x. This is the answer. And nasatisfy din yung equation natin. So, therefore, pati ito is a general solution. Is a solution, to be specific. Yan. Okay. So, that's it for this video.